Hello student, class 12th chemistry. I am Mrs. Hina Jangid. Welcome to my channel The Basics. Now I am giving you the second lesson of chapter 2 solution. So we had discussed earlier about the solutions, how solutions form, and about solute and solvent we had discussed. Then we had discussed about the concentration measure and the different type of solutions we had discussed, such as gaseous, liquid and solid solution. After that, I am going to discuss today about the solubility. Solubility means solute can dissolve in solvent at a particular temperature. At a particular temperature, at a particular concentration, a solute can dissolve in solvent. A solute, as you know, that solute is in lesser amount and solvent is in more amount. So we have to discuss the solubility. Solubility means dissolution power of solute in solvent. For that, one law is followed, that is like dissolves like. As we have discussed earlier also about the like dissolves like. Like means same type of substance can dissolve in same type of solvent. Such as polar solute can dissolve in polar solvents. Polar means which has polarity. Such as H2O, we know that in H2O, oxygen is having delta negative charge and hydrogen is having delta positive charge. So this is H2O, it is have some polarity. So we can dissolve HCl in it because HCl is having some polarity according to Pion's rule, H plus and Cl minus. So both are having positive and negative charges, means they are polar. They are having two poles, positive and negative ions in them. So like dissolves like, accordingly polar solute can dissolve in polar solvent and the non-polar के example हमारे पास क्या क्या है? Non-polar solvents. H2O is universal solvent as we know. And what are non-polar solvents? Non-polar solvents are such as CHCl3 chloroform, CCl4 carbon tetrachloride, then we have CS2 carbon disulfide, benzene is the best solvent, C6H6. These are non-polar solvent in which non-polar solute can dissolve. Those are not having any kind of ion. So we have to discuss here about the solubility of solid in liquid, such as we can dissolve in salt in water. Salt जो है NaCl, Na+ and Cl- can dissolve in water. So polar can dissolve in polar. So what is the effect of temperature on the solubility of solid in liquid? So solid जब dissolve होगा तो क्या होगा? When we increase the temperature, it depends on the Le Chatelier principle. Le Chatelier principle में क्या होता है? If the reaction is exothermic. For exothermic reaction, we know that delta H always will be negative. Means delta H will be lesser than 0 always. So for exothermic reaction, if heat is evolving in the reaction, so we have to decrease the temperature. And according for endothermic reaction के लिए क्या होता है? Delta H is positive. So we have to increase the temperature to proceed the forward rate of reaction. So solid can dissolve in liquid and they can form saturated solution, they can form unsaturated solution and supersaturated solution. So temperature का effect क्या है according to endothermic and exothermic reaction? According to Le Chatelier principle. Now the effect of pressure. Pressure का क्या effect है? Pressure is having negligible effect on dissolution of solid in liquid. It is having negligible effect. Now we have to discuss the solubility of gases in liquid. Solubility of gases in liquid directly affects by pressure and temperature. So first we have to discuss about the effect of pressure. Effect of pressure, we know that oxygen can dissolve in water, but it is slightly dissolved. But HCl, it can dissolve in water in high amount. So polar can dissolve in polar solvent. So this is the basic phenomena for that, like dissolves like. इसी को follow करते हुए हमें आगे बढ़ना है. So who has given about the relation in between the solubility of gases in liquid and the pressure? Who has given? Henry has given the relation in between the partial pressure of gas and the mole fraction. Solubility जो है, it depends on the mole fraction. Mole fraction earlier we had discussed. Mole fraction क्या होता है? One substance moles upon total moles. So Henry has given one relationship that the partial pressure of a gas is directly proportional to the mole fraction. This is mole fraction. It is related with the solubility. मीन्स जैसे जैसे हम प्रेशर इंक्रीज करेंगे द सॉल्युबिलिटी इंक्रीजेस एंड द मोल्स ऑफ सॉल्यूट दे विल इंक्रीजेस. सो मोल फ्रैक्शन के डायरेक्टली प्रोपोर्शनल है. सो if we remove the proportional sign, then there will be a constant that is called as kh. K is constant, h is for Henry, stands for Henry. So Henry has given this. P is directly proportional to the mole fraction, and this is the Henry's law constant. Henry's law constant, it is different for nitrogen, oxygen and other gases. It is related with temperature and pressure and the solubility. This is the relationship in between kh and the solubility. If kh is more, then solubility will be high. Solubility will be low. kh ज्यादा है तो solubility, तो both are reciprocal to each other. kh and solubility are reciprocal to each other. There is a table given in your book. You can see in that. If we plot a diagram, graph in between partial pressure and mole fraction, partial pressure और mole fraction के बीच में जब हम एक graph plot करेंगे तो that will be a straight line graph started from the initial point 0. So mole fraction बढ़ता जाएगा when partial pressure is increasing. This is increasing and mole fraction is also increasing. So this is a straight line graph. इस तरह से एक straight line graph आ जाएगा आपको. And the slope of this graph, slope क्या हो जाएगा इसका? That is kh. kh is the slope of this graph. We have to follow this equation y equals to mx plus c. So c जो है इसमें intercept is not there, 0 से start हो रहा है. So the slope will be kh is here. After that, what are the application of Henry's law? Henry law की क्या application है? There are 3 application. Those are given in your book. That if we increase the pressure, we can dissolve the gases in water easily, such like in cold drink. Cold drink में CO2 dissolve होती है, it can easily dissolve. After that, second is given for deep sea divers. Deep sea divers में जब हम जाते हैं तो ऑक्सीजन सिलेंडर ले जाते हैं. पहले क्या होता था? ऑक्सीजन एंड नाइट्रोजन. In deep sea, high pressure is there. हाई प्रेशर होगा तो सॉल्युबिलिटी ऑफ गैसेस विल बी मोर. तो क्या होगा? जैसे ही डीप सी डाइवर्स ऊपर आते हैं, स्क्यूबा डाइवर्स ऊपर आते हैं, तो क्या होगा? प्रेशर रिलीज होगा, प्रेशर कम होगा और उसकी वजह से नाइट्रोजन गैस जो है आर्टरीज में बेंड्स बना लेती, बबल्स बना लेती है और ब्लड फ्लो जो है वो रुक जाता है एंड हार्ट अटैक की प्रॉब्लम आ जाती है. सो टू रिजॉल्व दिस प्रॉब्लम व्हाट साइंटिस्ट हैज डन? साइंटिस्ट ने क्या किया? साइंटिस्ट ने हीलियम भी मिक्स करी. नाइट्रोजन, ऑक्सीजन एंड हीलियम का एक प्रोपोर्शन रखा जिससे ये प्रॉब्लम दूर हो गई. देन नेक्स्ट इज, अच्छा, स्क्यूबा डाइवर्स में जो प्रॉब्लम होती है उसको हम क्या कहते हैं? आर्टरीज में जो बबल्स बन जाते हैं नाइट्रोजन गैस के, दोज आर कॉल्ड एज बैंड्स. आपको नाम याद रखना है, दीज आर कॉल्ड एज बैंड्स. आफ्टर दैट द थर्ड इक्वेशन, थर्ड एप्लीकेशन ऑफ हेनरी लॉ इज, व्हाट इज द थर्ड एप्लीकेशन? एट हाई एल्टीट्यूड. हाई एल्टीट्यूड पे जब आप जाते हैं तो प्रेशर डिक्रीज होता है. प्रेशर डिक्रीज होगा तो ऑक्सीजन का जो लेवल है, ऑक्सीजन लेवल इन आवर ब्लड, दैट डिक्रीजेस. तो ऑक्सीजन लेवल डिक्रीज होने की वजह से हमारा जो ब्रेन है उसकी पावर सोचने की कम हो जाती है एंड ऑक्सीजन डिक्रीज होना वो क्या